Okay, so we've seen what the overall window looks like. Now we're going to go to the command window, and you can tell I'm in the command window because we have the title command window and because we have these two arrows, these chevrons at the start of the line. And we're just going to use MATLAB like a basic calculator. So there's lots of basic numerical manipulation you can do directly in MATLAB, and much of it is very intuitive. So if we type 2 plus 2, and I encourage you to type along with anything that's shown in a command window here. If you type in 2 plus 2, it'll show you that the answer equals 4. And we get the answer displayed on the screen. Many basic mathematical operators are included. So if you want to raise something to the power, you use that power symbol. So 3 to the power of 2 would be written like this. And that comes out as 9. Many more advanced functions, trigonometric functions, are also predefined like they would be in a graphing calculator. So if you want to do sine of pi over 2, you can do it like this. Notice pi, we didn't define that variable. It's already defined within MATLAB. So many numerical constants that you might need to work within MATLAB are already defined. You'll notice that every time I'm typing a command here, what's being returned to the screen is that answer equals and then the result of my function. So what does that mean? Well, that actually means that a variable called answer is being created every time I'm typing one of these commands. We can actually check what value that answer variable has by typing ans again. So if you type ans and hit enter, you should see the result of your last calculation. So we can check the value that that variable has by just typing ans and hitting enter. You can do things that other languages might cause errors. So if you were to do a divide by 0 in, for example, Python, you'd get a divide by 0 error. But in MATLAB, you can do 7 over 0, and it will tell you that that's an infinite number. So it's good for working with some of these more advanced mathematical cases where ill-defined numbers are actually needed. And you can use brackets to group your orders of operations. It will obey the standard order of operations, but if you want to group them with brackets, you can use as many brackets as you want. Don't be afraid of grouping things with brackets. It's not going to slow down your code. It's great, makes things clearer for everyone. So can everyone see why that would come out as infinity? If we go through it carefully, starting with the innermost brackets, what we have is 6 multiplied by 2, which is going to evaluate to 12. Then we have 12 minus 12. And then we do 10 minus 3 divided by 12 minus 12 will become out infinite because 12 minus 12 is 0. So you can raise things to the power using this engineering notation. So 1 times 10 to the 4 multiplied by 1 times 10 to the 6 would be written like this, 1e plus 0.4 multiplied by 1e plus 6. And overall it evaluates as 1 times 10 to the 10. So these are the common arithmetic operators that we're coming across. There is addition, negation, multiplication, division, exponentials, and you can use your brackets to order things the way you might expect. So there are ways of doing more advanced things, but these are the basics that you'll be working with. In some languages, you have to end every line with a semicolon. With MATLAB, a semicolon is used to suppress the output of a line. So it takes a while to get used to if you've been working with other languages. But in MATLAB, you only put a semicolon on the end of a line where you don't want any output from that line. So if I write 3 to the power of 2 and hit enter, it shows me that the answer is 9 on the screen. If I do 3 to the power of 2 and put a semicolon at the end of the line and then hit enter, I don't get the answer returned to the screen. I just get this blank line ready for the next line of code. However, in my workspace, you will see the variable set. So the semicolon will still let the line run, but it will stop any output being displayed to the screen. So rather than telling you that it's updated this answer variable, it will just silently update it. So most lines, as you write larger and larger code, you're going to put semicolon at the end of, because you don't want every line telling you what it's doing as you're going along. But if you're interested in, as you're debugging, picking out specific lines that seem to be not working how you'd expect, try taking the semicolon off the end and checking that the values are being updated as you might expect. The other way of controlling what code is run is using code comments. In MATLAB, code comments are with a percentage sign. So anything you write after a percentage sign is going to be ignored by MATLAB. So this means it's an easy way of writing any notes to yourself about what specific code does. MATLAB is going to ignore them. They're not going to impact the speed of your code at all. I encourage you to write as many code comments as you can, especially as you're following along with the workshop. Copy my examples, and as you understand what a line does, add a code comment next to it to remember what it does, and that will help jog your memory when you look back at the code afterwards, so you can understand what each line does. Okay, so I told you about the workspace and how we have the variables that we're using listed there. There's two ways of doing things in MATLAB. You'll see that some of these lines contain an equals and some of these lines don't. If you write a line that doesn't contain an equals, it's going to update the ans variable. The ans variable will be updated with whatever you've typed. If you type a line with an equals sign, then whatever variable name you put on the left of the equals sign is going to be updated with the value of whatever's on the right of the equals sign. So you set any variable in MATLAB and update any variable in MATLAB the same way by typing variable name equals and then a variable value. So if I do 3 to the power of 2, I've put a semicolon at the end to suppress the output, and then I've written a code comment which MATLAB will ignore. I hit enter, and what it does is it sets the ans variable to 9 because there was no equals on that line. I can then do x equals ans, which will set x to have the value of whatever ans was. So now I get this x variable that's arrived, and its value is 9, the same as the ans variable. If I do y equals 3, creates a y variable, sets its value equal to 3, you should see it on the left in your workspace. And if you do you can do more complicated statements and save their results to variables. So if I do x multiplied by y, it knows that x is going to be 9 because it's whatever the value ans had. Y is going to be 3 because we set it in the line above. And so we get this 9 multiplied by 3, and z gets the value 27. Just because a variable isn't listed on the left doesn't mean that it's not defined. We saw that pi was defined just now. And there are some other variables defined by default, like I is going to be an imaginary number in MATLAB. In other languages, you'd be able to, I would not be predefined. So be careful when working with I. We're not going to be getting into imaginary numbers here, but it's just something to be aware of, that some variables that you might not expect are predefined. That doesn't mean you can't overwrite them. If you want to write a loop that uses for I equals something, you can go ahead and do that, but you've now overwritten the imaginary number that's been stored there. So the variables you've defined will all appear in the workspace. There's going to be some extra variables defined by MATLAB within your environment anyway, but you can overwrite them and ignore them. That's totally fine.
What's the minimal number means here?
So in your workspace, you may or may not see all these headers. The question was, what does minimum mean here? The answer is that sometimes you'll have lists here. And if your variable contains multiple numbers, MATLAB will tell you what the smallest number in your list is, what the largest number in your list is. And if you right-click on the column header, you can actually add other values here. So for example, if I want to know what class my data is being stored as, I can do that. You might need to expand things to see everything. But now we can see that my variable is being stored with double precision here. And you can add and take away columns as you require. There's a bunch of columns. So if, for example, we'll come across lists soon, but just to inform you, if my var is 1, 2, 3, 4, 5, we look in my var and it will show me the min is 1, the values are 1, 2, 3, 4, 5, and the maximum is 5. So it's going to tell you some information about the variables. It's useful if you're working with a large data file. You want to make sure that your plot contains all your data. You can quickly glance at the min and max and adjust your axes accordingly. So it's useful for some things rather than having to type a separate command to figure out the minimum and maximum. Okay, be aware that MATLAB is case sensitive. So capital X is not the same as lowercase x. While those two variables are different, I would not encourage you to use that when you're writing code. Don't define an uppercase x as one thing and a lowercase x as another. It might make your code small, but it's also going to make your code very hard to figure out. Use long descriptive variable names. One habit that you might like to get into if you're beginning programming is what we call camel case, where the first letter of every word is going to be capitalized. It's meant to look like a camel's humps, and that would be like capital C between your words like this, so you can see where one word begins and the other word ends. You can use underscores and other things in your variable names if you want, but the easiest way is often to just capitalize the first letter. If you make a casing error, MATLAB may warn you and say that that variable is undefined, but perhaps you meant the lowercase version, and it will give you a little bit of information about perhaps your capitalization was wrong. But just be aware that case matters and try and be consistent. Okay, so everyone should now have created a few variables in their MATLAB environment. Let's say you've done your coding, you've come to the end of your day, you want to pick up again where you left off tomorrow. What we're going to do is we're going to save our current state and then reopen it. So in MATLAB, that's fairly simple. If you type save and then give a file name, so I've here did save space my file, hit enter, what it's going to do is it's going to save my workspace to a file in my current directory, which is whatever is shown on the left in my working directory pane. And you should see, after you type that and hit enter, that there is a myfile.mat.matlab file that appears in that workspace. Once you've seen that being created, I want you to close out of MATLAB totally, just so you trust it, so you know that I'm not lying, that you can close out of MATLAB totally, shut down your computer, come back the next day, reopen MATLAB, and you'll see that your workspace is empty, but then we can reload the workspace by typing load space myfile.mat. And that will take us from this empty workspace with the file there in our current directory, but none of the variables loaded, to a state where after we hit enter on this line, that the variables that we defined previously are now loaded into our workspace. So whatever variables you had before should be back there ready to work with.